Okay, in this video, I want to cover a little bit more about graphing parabolas. So the last couple of examples that you saw from the last video, we had the nice benefit of the parabola being centered around the y-axis, or in this case, the f of x and g of x axis. But now let's take a look at some situations where perhaps it's not going to be centered. It's not going to be centered along the vertical axis. Let's take a look at what we need to do here. So the first thing we need to look at is something called the vertex. So the vertex, if we look back to our previous examples, this is what you can think of as either the highest point on the graph like this one, or the lowest point on the graph like this one, okay? So if the graph opens up, it's your minimum on the graph, and if the graph opens down, it is your maximum for the graph, okay? So, if we are given an equation of the form y equals x minus h squared plus k, the vertex is just given by hk. Okay, so let's take a look at this example here. Here we have y equals x minus 3 squared minus 4. Okay, so it's the first thing we have to do anytime we're given an equation like this is we need to put it in the form y equals x minus h plus k. Okay, so here we're pretty close. We have y equals x minus 3. So here h is going to be equal to 3. Okay, but we have h minus x minus h plus k, but here we have minus 4. So we can actually rewrite this as x minus 3 squared plus negative 4. So here, that means k is going to be negative 4. So our vertex is going to be given by 3, negative 4. So that means we can go to the right 3 and we can go down 4, and our vertex is going to be right here. And so now, if we want to figure out what this graph is going to look like, we need to plot some points. So we'll put x here. We will put x minus 3 squared minus 4 here. And then our points are going to go here. So this will be x, y. Okay, so the way to do this is you want to plot x values that are to the right and to the left of this vertex. Okay, so the x value here is 1, 2, 3. That is, we're sitting at x equals 3. So we already know what x equals 3 is. Let's try x equals 2. Okay, that'll be just to the left. So we'll have 2 minus 3 squared minus 4. That equals negative 1 squared minus 4. Negative 1 squared is just 1. Minus 4 is negative 3. So we'll have the point 2, negative 3. So we'll go 2, and then we'll go down 3. So we're going to look about like this. Okay? Now we want to get something just to the right here. Okay? So if we go just to the right of 3, we'll have x equals 4. So we'll have 4 minus 3 squared minus 4. And this is going to be equal to 1 squared minus 4, or just 1 minus 4, and that's negative 3. So I have the point 4, negative 3. So we go over 4, and we go down 3. Okay, and then we'll go one further to the left. So we'll put in x equals 1. So we'll have 1 minus 3 squared minus 4. Okay, 1 minus 3 is negative 2. So we'll have negative 2 squared minus 4, or that'll be 4 minus 4, which is 0. So we have the point 1, 0. So 1, 0. And what you'll notice here with these, that was something I wanted to mention as well. What you'll notice is that as we keep plugging in points, next we're going to do 5, you're going to notice there's some symmetry across this vertical strip right here. So we're noticing there's a mirror image here. So my guess would be, if this follows, and I know this is what it's going to be, is that we should end up with the point 5, 0 if we're correct. So if we have 5 minus 3 squared minus 4, that's going to give us 2 squared minus 4, which is 4 minus 4, which is 0. So we'll have the point 5, 0. So this is roughly what your graph is going to look like for this parabola. Okay, let's try another one. Here we have x plus 1 squared minus 3. Okay, so it needs to be in the form x minus h squared plus k. So we can rewrite this as x minus negative 1 squared plus negative 3. Okay? So from here, all we have to do is find our vertex. So our vertex is going to be negative 1, negative 3. Okay, so that's our vertex, negative 1, negative 3. So we go negative 1, go to the left 1, we go down 3. And then we can just honestly plug in a couple of points on either side. So we can do for, so the table here we have x. Not sure what's going on here. Pencil is not working. Okay, so we have x. So we're having some technical difficulties. Let me plug in my pencil. Okay, hopefully that did it. Okay, I am not sure what's going on here. Let's try this again. Okay, so we have our x values. We have x plus 1 squared minus 3. And then we have our points, x, y. Okay, so we want to plug in points on either side. So let's start with one to the left. So we'll do x equals negative 2. So we'll have negative 2 plus 1 squared minus 3, which is going to give us 1 squared, negative 1 squared minus 3, which is going to give us 1 minus 3, which is minus 2. So we'll have the point negative 2, negative 2. So we'll go to the left 2, we'll go down 2. And then if our symmetry holds, we should have 0, negative 2 as well. So let's try that. So 0. So we have 0 plus 1 squared minus 3. That's going to give us 1 squared minus 3, which is just 1 minus 3, which is negative 2. So we're going to get 0, negative 2. Look at that. Okay? So what you can do with these parabolas is you really only have to graph one side because you can take advantage of the symmetry that we have here. So let's graph one more. Let's graph x equals 1. So we'll have 1 plus 1 squared minus 3 is equal to 2 squared minus 3, which is 4 minus 3, which is 1. So we get the point 1, 1. So that'll look like this here. And then we should be able to just go over here and take care of the symmetry. And this is what this graph is going to look like.